Well, there's a study guide. Yeah.
Oh, that's right.
I did tell you there's a study guide on the for the final posted on my webpage. But what it does is it's not going to, I mean, those aren't the questions that you're going to see on the final, but it'll help you gear as to what type of questions to expect in terms of what kind of math to review and brush up so that you don't just start at the beginning of the book and try to read the whole book before you start. So go back and say, like I'll say, question 17 on chapter, page whatever, or homework question whatever, what concepts, look through that, see what kind of question you'll say, oh yeah, okay, I remember doing this, and then go back and kind of do that. Otherwise, it's just going to be a ton of information to try to synthesize. Okay, what is a horrible idea? It's past the point of rescue for some of you, but what is a horrible? I don't mean that in a bad way. I'm just being honest. What's a horrible idea is to try to procrastinate in a chemistry class. Okay, if you haven't learned that the hard way yet, and I warned you adamantly so at the beginning of this class, don't do that. I don't care if you do it in the other classes, what you memorize, whatever, but you will be sunk in this class if you try that. Okay, so you got to stay on top of this stuff. I'm serious, because if you wait, you're going to be done, and you're going to have to be sitting in here for the next semester and the semester after that. And sometimes I've got plenty of repeats. Okay, so I don't want you to do that. I mean, I don't. My classes will fill with or without you. I don't. It's nothing personal. I want it for your sake. I don't want you to have to sit through all this again. I think it's great. I think it's fun. I would love you. I would love you. I would. Oh, I love all you guys. I would love for you to come back and take every chemistry class possible, but we both know that's not a reality. Okay, so I want you to get out of this what you can. No. Oh, you do, yeah. I mean, I'll teach whoever wants to sit around, but I'm just saying, there's no sense in. There's a difference between what you learn, and what's nice whenever you get done with school is there's a difference in learning what you have to learn and what you want to learn, right? Because even with chemistry, you might find some of this stuff interesting when you're all done, but when you're not getting graded on anymore, it's a lot more fun to learn. Okay? But at some point, someone's got to hold you accountable for learning it. Otherwise, you'll just sweep it under and procrastinate and never do anything. So it's a double-edged sword with the whole grading process. I would love to be able to say, you know what? Forget about grades. Let's just come in and learn. But we all know that will not work. For some of you, that will work. But for most, it will not work. And I have to hold you accountable for that. And that's why things are hard. That's why I have to do the things that I do. Okay? And I hope you can understand that. And if you don't, well, I'm sorry. But that's just the way it is. Okay, let me give a couple more here. I don't need to review this. We've already discussed this. What makes a strong acid a strong acid? What makes a strong base a strong base? It's dissociation. And remember that when things dissociate, that's electrolytic solutions as well. Electrolytes are things that fall apart and conduct electricity. So obviously strong acids are going to be better electrolytes than weak acids. And same thing with bases. Okay, so that's that slide. And this is a visual illustration if you couldn't grasp that. So let's skip this. We can use, this is just to show you in terms of the ability to conduct electricity. If there's a power source over here that's supplying this, and it goes through, if this circuit was broken and whatever the solution was, like in pure water cannot take it and move from this electrode, come in contact, pass that electrical charge between water atoms, pass it on to this electrode and out and complete that circuit. Pure water will not do that. It's not dissolved ions. However, if you take a hydrochloric acid solution, notice the light bulb is glowing now. You can complete that circuit. Okay, it will flow all the way around because these ions will transmit electricity. Distilled H2O. Not like tap water where there's tons of ions in it. Yeah, there's iron, magnesium, calcium, you name it. Okay, even some nice radioactive radon. Hydrogen sulfide, if you got well water, it makes it smell like sulfur and sulfates and iron that turns it all that orangey rust color. And that's good stuff. Yeah. Okay. I talked about weak acids already and how they don't dissociate completely and they only get rid of some of their hydrogen. So that's what this slide shows. It's actually, you would be surprised just how weak some of these are. Most acids, weak acids, when you drop them in water, actually much less than 1% of the molecules are actually ionized in water at any given time. So you don't have very many at all that are actually ionized. Okay. Now, weak acids, because they don't ionize nearly as well, they don't conduct as well. So you see that this light bulb is much dimmer in terms of its glow. Water, again, for our control, nothing. Hydrofluoric acid, which is a weak acid, it stays intact more, doesn't separate very well, so it doesn't conduct electricity nearly as well. We have sulfuric acid, which is a strong acid in our car batteries. You know, it's got to be able to conduct around those lead electrodes that are in our car batteries. That's why they're so heavy, because it's all plates of lead in there. Well, that's I got a lot to talk about for that. We have, well, I mean, you can understand it if I explain it, but there's a whole concept of electrochemistry. We'd have to talk about different atoms and their affinity for electrons and how water plays into that. And it has to do with some hydrogen replenishing, but also some other things. I can't talk about it right now. Okay. We talked about strong base. No, I hate to say that because I never want to say that. I never want to say it just does because there's an explanation, but I can't. I don't have time. Set in the next semester. Take Chem 2 for the fun of it, and I'll teach you. I'm going to skip over this just to answer that, right? Now we'll talk about fission and fusion bombs, and we'll talk about all kinds of cool stuff. Radiocarbon dating. You know. All right. I'm going to skip through this week's strong stuff. We've already talked about it. So we've already talked about why, for example, the conjugate pairs are like the way they are. Why does a strong acid yield a very weak conjugate base? Because of the level of attraction between the hydrogen and the anion. Okay. Do what? Well, if you have like hydrochloric acid, okay, if you have H and Cl, hydrochloric acid is a very, very strong acid. That means it likes to do this. It likes to fall apart. So that means the conjugate base of hydrochloric acid is that chloride ion, right? Does it want to be a good base and suck back a hydrogen very well? No, because it already fell apart, right? So the strong acid means it falls apart really well. The base is going to be very weak. The conjugate base of it's going to be very weak. And that's what all this is explaining here.
So other than left
As far as acids go, really it's something you just have to get used to. As far as bases go, they're easier. All your hydroxides are really strong. And your ammonia is, well, that's actually kind of weak. No, just have to get used to them, memorize them, I guess. I mean, if you see anything like HCl, H2SO4, HNO3, some of these acids that I talk about we use in lab, those are going to be strong acids. The only kind of familiar acid that you will see that is not a strong acid is acetic acid. Acetic acid is actually the vinegar is a weak acid. But I'll let you know. I mean, I'm not just going to have you memorize some big table for the fun of it. Okay, I already talked about this. Already talked about all of it. Oh, all right. This is a good place to stop. We'll start with this next time.